Good afternoon. Welcome. We're so happy to see everyone joining us today to talk about GIS programs at the University of Vermont. Thank you so much for joining us. My name is Nicole Willie-Fenton. I have the good fortune of working today and sharing this presentation from Dr. Galford and Dr. Armstrong as well. So we have Gillian Galford with us. She is our program director of our GIS Certificate program at the University of Vermont. She's a research associate professor and academic director of UVM's Geospatial Technologies program, and we're so happy to have her leading our GIS program as well. So we also are so excited. Dr. Armstrong is teaching for the first time with us at UVM in our program, so we can't wait to hear more from her today. And Dr. Armstrong is a senior research scientist at NASA, and she is with the Goddard's Earth Science Technology and Research program, and she is leading our Remote Sensing Foundations course, and we're going to hear a lot more from Dr. Armstrong in just a few minutes. So as I mentioned, we're going to talk about remote sensing. What is it? We're going to deep dive into the Remote Sensing Foundations course that starts in a few weeks, May 23rd. We're going to do an overview of the GIS, the Geographic Information Systems and Data Communication Certificate program, course logistics, learning objectives, and of course, what can you do with it, right? That's always a great question we get. What can I do with this learning with GIS certificates? So we'll talk about that because there's lots of possibilities, and we'll have plenty of time for your questions. A few housekeeping before we dive right in. This is being recorded. We will share the presentation with everyone who has RSVP'd, and please do put your questions in the chat box. I've got it on my left screen over here, so I'm keeping an eye on your questions, and please do ask those throughout the presentation. Okay, let's get going. Gillian, do you want to take us away and just ground us in what is remote sensing?
Sure. I love remote sensing. It's actually my primary field, so it's really fun to be talking about this today. Remote sensing is one of those terms. It's difficult to provide a definition without using the word in the definition, like our school teachers taught us. But really, remote sensing is the science where we obtain information about objects from a distance. So most of the remote sensing information that you might encounter in your life would be aerial photos or satellite images. Those are probably the most common things. But we also think about like the rover on Mars as being a type of remote sensing. We didn't go to Mars, but we're able to collect data and information of it. This is an artist's rendition of a satellite called Terra. And on it is a particular sensor called MODIS. And MODIS is collecting information about the Earth's surface and has been for several decades. So it's a very common remote sensing data set that you may actually have seen in your day-to-day life and not even realize it. And most people are seeing satellite images quite frequently now because of how much we use them in apps like on our phones, such as Google Earth, and so on. This is a schematic showing you on the left some of the common types of remote sensing we use to study the Earth. So these types of information could be collected about land, about our oceans, our biosphere, our atmosphere, but they can be collected at different scales or different resolutions. So we might have a satellite that's continuously orbiting the Earth and collecting information. We might have a one-time airplane excursion that has a sensor and collects information about the Earth's surface. More frequently, we're also using drones to get really high resolution images of the Earth in very specific places and being deployed in GIS context. So on the right side, you see a schematic where we're combining different types of information, roads, buildings, vegetation. So something like a remote sensing image of the surface might give us information on vegetation, but increasingly it's being used in disaster response. So right here in Vermont, a couple of years ago, a team from the University of Vermont deployed drones to look at a train derailment and then help inform disaster response to that train derailment. So combining different types of data to inform the state on what had happened in this remote area. So remote sensing, we might collect things like satellite images, but it's also about what we do with that data. So this is an example provided by the NASA Landsat team, and Landsat's one of the most common satellites. And certainly I think students will have a chance to interact with Landsat data in this course. So in this project, these Landsat scientists mapped impervious surface across the United States. So that's, you can think of it as paved areas, roofs, roads, things like that, that water runs off of. And then they also looked at the temperature of those paved areas. You can imagine if I sent you out to measure the amount of paved area in the United States, it would cost us a lot of money to get that work done. It would take a lot of people and a lot of time. So remote sensing sometimes can help us obtain data in really remote areas, obtain data over very large areas, and understand things, extrapolate quite a bit across very large areas. And then it can be combined. So we might take this remote sensing product and combine it, say, with analysis of socioeconomic characteristics of really hot areas, urban heat islands, and so on, to understand who's at risk from the findings here on high temperatures. One of my favorite things to do is look at satellite images. And if you're someone who just likes looking at Google Earth in the satellite view, remote sensing is probably for you. I like to say that our brains intuitively understand a lot about about images. And I picked this one in particular, and I would ask you, what do you observe? What do you notice? And you probably observe or notice more than you are aware of. So for example, you might notice that this is South America. You might be able to tell me where the water is or where there's some snow-capped mountains. Your brain might understand some things about vegetation, and where in this image, darker green is more dense, wet vegetation, and then lighter colors have less dense vegetation. And in fact, this is a part of South America where some of the lightest brown colors are actually showing us areas of agriculture. So this data was input, and Nicole, you can hit the next slide, to a number of processes, so computer algorithms that then would automatically map areas of forest that were deforested, where the forest was cut down. So with remote sensing, we really start with a lot of our human intuition and human understanding of an image or a data set. And then we try and figure out how to use our computer applications to extrapolate the patterns that we think we're observing in the data. So this is one example where that's been done for South America.
Super cool. Thank you so much for giving us a foundation in remote sensing. And now, Dr. Armstrong, we're going to toss it over to you to take that information and how it will apply into the course that you're about to teach.
Yeah, great. Thank you. That was actually really great. I was kind of lulled into watching sort of the lecture unfold a little bit there. So thank you. So this course, we're going to learn about how remotely sensed images are measured and processed, and how they can be applied to answer key scientific questions that we're interested in. Here's an example of satellite imagery collected from Landsat, which is mentioned is a really commonly, it's one of the most commonly used sensors. It's got very highly abundant spatial and temporal coverage of the globe. So the left shows a black and white image that is broken up into bands of different spectral wavelength ranges. And then if you look at the middle, basically we can select 3 of these and assign them different colors. And then over on the right, we take those 3 colors and what we've made is what's called a false color image. So we're here, we see the vegetation is in red. And if we do this with multiple images over time, we can also gain an understanding of how vegetation might be changing, how the makeup of that vegetation might be changing based on the redness of it, for instance. And so this is just one small example of what we'll be able to do with the tools that we learn in this course. Next slide. So yeah, the course focuses on a solid conceptual knowledge of remote sensing. So what is it? How does it work? And then from here, we'll learn how to use these key tools to carry out a lot of the commonly used applications for remote sensing. So we will develop, basically we'll demonstrate a bunch of the physical processes involved in the acquisition of remote sensing imagery. We'll also build a working knowledge of all of the different geospatial data sets that are out there. And then we're going to be using Google Earth Engine code editor to create workflows, and we'll be able to share a lot of the codes that we develop with each other to help learn, and kind of advance our understanding and knowledge as a group. We'll also practice some data visualization techniques. There's a lot of different really cool APIs that Google Earth Engine has in the code editor, so you can create GIFs using Google Earth Engine, for instance, or small videos, things like that, looking at time series analysis. We'll also maybe delve a bit into some multispectral, multitemporal image processing techniques and image classification. And so from this, I hope that the students will gain a better understanding both of remote sensing, but also of the different types of analyses that we can apply using remotely sensed imagery, and actually how we can visualize the data as well. Next slide, please. Okay, so this is just an example showing the Google Earth Engine API. It's a really interesting and free, which is great. It's open sourced. So this is, in the past 5 or so years, become a very heavily utilized tool across the world. And one of the things that I love about Google Earth Engine is that you can be anywhere in the world. All you need is a laptop or a computer and an internet connection, and it's cloud-based computing. So whereas before, back in the old days when I took remote sensing classes as an undergrad, you would have to work with computer software that would be downloading individual images. And as we'll learn in this course, images are very, very, very large, and it requires a lot of data heavy lifting to be able to process the images, analyze them, understand them, overlay them with each other to do analyses. Here, using Google Earth Engine, we can use JavaScript to write code that basically sends out these batch processes to do all of that data heavy lifting for us in cloud computing. So that's what we'll be using. That'll sort of be the backbone of the course. We'll be learning how to manipulate and analyze remote sensing data using Google Earth Engine.
Awesome.
Next
Thank
slide.
you. Thank you. And I know too, thank you, both of you, for making mention about Google Earth Engine, and Gillian put a link in the chat. So make sure that you check that out. And I think what I'm hearing too, and Gillian, I know you'll touch on this, is not just, access to some software that you might not have access to through this program. And then with Amanda too, learning how to manipulate and utilize some of the software that everybody has access to. So such a great combination of using software that you might not have access to, and then how do you use software that is open source. So thank you both. I can't wait to hear more about that. So let's back up a tiny bit. And on this slide, it's really starting to look at the full certificate, the full GIS certificate, of which the remote sensing is one piece. Do you want to walk us through these next couple of slides, Gillian?
So the professional certificate is designed for people who are not currently enrolled at University of Vermont. So you're not working on your master's degree, or you're not getting a bachelor's degree, but you want to continue learning in these areas. So we've built a series of very rigorous courses. They are totally equivalent to taking a college course, but they're for non-degree students. So a lot of our students are professionals looking to either shift careers or advance in their current position. We've designed the the certificate to be completed with a series of 4 courses. You can choose any 4 courses that you want. We offer more than 4. Ideally, you can complete this within 8 to 12 months. We're seeing some people finish quite fast, and other people, sometimes personal circumstances take longer. So we'll work with you on that as you need to. We have classes starting on summer, fall, spring, with multiple starts at different times. You do get a digital badge, which you can include on resumes, LinkedIn, and so on. So overall, the purpose of the GIS certificate is to give you both the conceptual understanding of GIS, remote sensing, data visualization, and communication, as well as how to use them in really practical ways so that you are ready to use them, say, in a job or so on. I noted here at the bottom some of the software programs that you may be exposed to, programming in Python or in R, in the Google Earth engine using JavaScript. And then we also use ArcGIS Pro for the GIS courses. Nicole, I did notice a question came in the chat
Yes.
about coding and the knowledge of APIs. So this is a really interesting point that for example, some people get into this type of work because they come from a computer science background. If you're like me, that's not how you got here. I got here because I was interested in the science and the applications, and as a result, I've learned some of the coding. So particularly an intro to GIS and this remote sensing course, we don't assume that anyone has any background knowledge or depth of skills in this area. It really starts from scratch. And so it helps you build from that sort of baseline of not having much knowledge.
Awesome. Thank you so much. And thank you, Kristen, for asking that question. It's one we often get. So thank you so much for making note of that. And on this slide, a little bit of the information that Dr. Galford has talked about, but also a little bit more detail. How much time might this take you, especially because we do see a lot of working professionals. So maybe just touch on a few points here, Gillian.
Yeah, so most of our courses run for 8 weeks. They're designed so that you spend about 10 to 12 hours per week. So it is a substantial time commitment, and that's doing all your assignments and readings. The course over the 8 weeks, it is asynchronous, so it's self-paced, but you are responsible for weekly modules. So you're not just let loose for 8 weeks, but you have weekly deadlines and check-ins that are due. So you may have readings, videos, and then you'll have hands-on interactive assignments.
And as I mentioned, Amanda's course is coming up quickly. And so we're very excited. We already have lots of enrollments in the course, but we have lots of room too. So if you're interested in Remote Sensing Foundation, that is starting on May 23rd. And then we often get this, I won't read off the dates. You can see those on the slide, but Gillian, we always get this question. Intro first, advanced? Do I follow the sequence? How do I sequence these, or what would you recommend if people have some experience and then maybe no experience in GIS?
Yeah, if you're thinking about our GIS courses specifically, I would look to your experience with ArcGIS Pro, which is a new version of Arc that has a substantial change in its user interface. So some people who have worked with ArcGIS in the past have chosen to take Intro to GIS to really get sort of a foundation and basic understanding of the new version of the software because it is so different. Some people perhaps took one GIS course previously or have used it in the workplace and feel comfortable going into advanced GIS. I usually point people to our website to sort of look at the skills and learning objectives for each course to understand, okay, do I feel comfortable going straight into advanced or do I need to start with intro? For remote sensing, Amanda can jump in here, but it certainly helps to have some background in GIS. So if you've already done GIS, you might find some concepts are helpful in remote sensing. But it's not strictly required that you have completed the GIS sequence before you take remote sensing.
Amanda, do you want to jump in and add anything else to that, just in case people are kind of curious what some of those, not really prereqs, but just some of that pre-learning might be to take your class?
Sure. Yeah, so I think I would go along with what Professor Galford just said. I would say that it's not required that you have background in any GIS course. I think given where we're starting and where we're planning to go in this foundations course, some of that will be able to be understood. Just kind of a basic background of geospatial analysis. But I think, and same thing for the earlier question about coding. I'm also the same. I came from a rote scientific background. I apply remote sensing. I use remote sensing in my day-to-day work. I work with a lot of NASA products. And I work with the engineers that develop these products, but I don't necessarily code the products myself. So I come at coding from a post-grad perspective also. And so I think, given this course and given the scope of the course, I think it's completely appropriate for a complete beginner and novice to both coding and remote sensing, and to be comfortable and not overwhelmed.
Awesome. That's great to hear. Hopefully that helps, Kristen. And I do know Kristen has another question, and I don't know how far you can see in that crystal ball, Gillian, as to when we might be offering remote sensing again.
Yeah, I don't think officially I'm supposed to say, but we're our intention, Kristen, is to offer it next spring. Okay. So it'll be awesome. Less than a year, but it's a little ways out. It's not in the fall, for example.
Great. Okay. Thank you. And thank you, Kristen, for keeping those great questions. And so we've talked a lot about different skills, and some that you need and some you don't need coming into this. But I always find that this slide is really interesting because it goes beyond just remote sensing. It goes beyond just geographic information systems. So maybe Gillian, and I'd love to hear from Amanda too, what are some other skills that people walk out of this type of course and this certificate with?
Sure. This is a list that I pulled from across our certificate program. So these are really some of the key skills that we wanted students with the certificate to leave our program with. And I compiled these, or really we designed the courses around these skills based on what we see in the job market. So these are some of the most common skill sets sought after in job postings relevant to GIS or remote sensing. And increasingly, I have to say that I am seeing job ads specifically calling for experience with Google Earth Engine, and not even deep experience, but at least some working knowledge of how to work with it. And so these skill sets would set you apart if you were looking for a new job or a job transition.
Wow, that's really great to know. Anything you wanted to add, Amanda?
I would just say that I think, in taking these courses, basically a key skill that you'll acquire is the ability to be able to decipher what you're seeing when you're looking at any sort of a map, whether it be something that is a GIS map of utilities, to reading an article in the New York Times about climate change, and understanding what you're looking at and what you're seeing, and that satellite imagery is not a picture, but it's data points, and how we can differentiate between these different types of data sets, and what we can use them for. So I think that that might be a little harder to list in a bullet, but I think that's also a really important skill, regardless of what your intended career is.
Great. That's such a great transition to this slide too. I want to get over to this, but let's pause for just a second, Amanda, while we still have you. The question from David: will application, and I don't know if I'm going to acronym it, or LIDAR, be covered in the remote sensing module or course?
Yeah. Yes, I do plan to talk about LIDAR, and how it's used, and hopefully we can work with some LIDAR. There's it's a LIDAR that's on the International Space Station called JEDI, that is a LIDAR, and it's basically a laser scanner, and scans and looks at. We can use it to look at canopy height, and structure for a structure. So yeah, I think we'll talk about that, and I think that also it's good to point out with this course that there will be some project-based learning. So I'm interested in students that have questions and want to seek knowledge out. If they're interested in LIDAR, then maybe their final project could have something to do with LIDAR, and they'll be able to learn more and more about LIDAR by working with the data. So yeah.
Awesome. Super great question too. Thank you. Yeah, thank you, David. You're so welcome too. Such a great transition also just into application of this information. And both of you come from a scientific background. And so I think it's fitting, of course, that you see some environmental scientists, urban planner, things like that on this list. But maybe Gillian, what are some things that might surprise people that it would be on this list that you could do with this knowledge?
You know what I like to do, actually, Nicole, is I do this with my students. I go on glassdoor.com, which is a jobs clearinghouse, and you can search for a particular location. So maybe you live in Virginia, or you want to move to North Carolina. Put in a particular location and put in GIS and see what jobs come out. I'm always surprised how many pop up, in business sectors that I hadn't thought of: transportation infrastructure and logistics, a number of things like that. I see a lot coming across the jobs listservs on supporting town planning or supporting municipalities in terms of just making really straightforward maps, but how important that is even for small towns, small communities across the U.S.
And I always think the healthcare data analyst always surprises me on this list to think about that from a GIS certificate. So I think lots of opportunities there, which is really great. So we're just winding down. We have a few more minutes, but just wanted to give an opportunity if you have any additional questions for Dr. Armstrong or Dr. Galford. As I mentioned, the remote sensing course is starting May 23rd, so we're very much looking forward to that. And if you have any additional questions too, there's always, mostly always about 9 to 5 each day, or 8:30 to 5, there is a live people on chat on our website as well. So you're not talking to a robot, you're talking to a real person. So if you have questions, please jump on our website and chat with us. You can email us, and lots of information about the certificate program and these courses that we've reviewed today is on our website also. So while I see maybe Krista might be typing one more question, I just wanted to zip back to this just so that we can have a sense as to timing as well. Yep, just a thank you. You're welcome, Kristen. So I think Gillian, unless there's anything else you wanted to add, I know we covered a lot today, but I think we're in a good spot.
I'm excited about Amanda's class. I have studied remote sensing for over 20 years now, and I think that there's going to be a lot of fun in Amanda's class, and I'd love to sit in on it too.
Sounds awesome. Yeah, we're super excited to have you on board, Amanda. Thank you for joining us today. And I know students that are already signed up are really looking forward to the class starting in a couple weeks. So, all right, from there, we'll sign off, give you back the rest of your afternoon. Thank you both for joining us and sharing the information about the certificate and the course. And thank you, everybody who joined us. We wish you well and a wonderful afternoon. Take care.
Thank you.